students, as I announced before, this chapter is very important to understand your project B. You have only 4 weeks to complete the project B. I don't think it's enough time for those who do not understand what is a query optimizer, and programming skill is not very important in this implementation. Okay, as long as you can understand basic syntax of your program language, it doesn't matter which program language you use, even though I mentioned the Java JDBC as an example in the project description, but you can use any program language. However, in your implementation, you need to understand the query optimizer, the concept of the query optimizer. Then you should be able to access the catalog metadata for the query optimizer, then implement the cost function that we are currently discussing about. Okay, that is the most important. But once you understand how the query optimizer is working, then the implementation itself is just the time matter. But it doesn't take a very long time. But I believe the first part is whether or not you can understand the concept of the query optimizer. To do that, this is the general process of the query processing. So in your implementation, you are going to definitely implement each part. But to simplify the problem, you don't have to implement the full, the standard parsing and the validating. Especially for the validating, no, you don't have to implement. However, for scanning and parsing, why don't you try to do your best as simple as possible? Okay, just like it doesn't matter how you write the implement. If you know the much about the compiler or the lexical analysis and so on, you can use it. Otherwise, you can use a simple text input form. Okay, then you can tokenize by the column. By at least your query should follow the SQL standard. Okay, which means the column can be separated by the comma and table can be separated by the comma, and also the where clause, it includes the selection condition as well as the join condition. So such a join and the select condition separated by the logical operator like AND or the parentheses. So by using such a basic the scanning and parsing, we can make the one SQL block to perform the query optimizer. You should know especially what column you are going to use in your query for the selection condition and join condition, right? So depending on the selection condition, you can use primary. You can use the no index. You can use the clustering index or something like that. That we are going to discuss the details the next week about the index itself. But to give the one more week for more time to implement the project B, I'd like to actually change the order. So even though you do not understand fully about the index, don't worry, don't be frustrated. But while you are, there might be no problem to start your project B1 first part without understanding the index. But it determines how is the query optimizer determine which option you have will be selected. Okay, then query optimizer implemented. However, we do also to simplify the problem, we are not going to consider many other options like how to implement order by or the group by aggregate function and heuristic, the query optimizer or rule-based optimizer. We are not going to consider such a only focus on the simple select join operation. Okay, selection condition and join condition we are going to focus on, and especially for the join condition, I'm going to allow the up to 2 table join. It's one join operation. One join condition is enough. So if we want to, you can implement the 3 table join. That will be much more complicated, right? So it's a 3 factorial 6 different join are possible, and each the join, it has the who we discussed today, different options. So please focus on the selection and join operation. So I'm going to explain about the project B description after we finish today's lecture. Okay. So then output is the plan to access. Okay. Plan to access means it's called the execution plan. Which table you are going to access first, then how. Okay? The how means we learned about the different option. Here, the linear search, binary search, primary index, and the multiple record, and the clustering, and so on. But I'm going to, during the explanation about the project, I'm going to restrict the search options too many for the first time. So we will limit. So we are going to use some of them that can be automatically determined by what? The index that we are going to create. Okay, it's a given. So such information I will explain in the project B1. So first you should be able to understand the project B1 before you implement the query optimization. First part is you implement everything except the cost function that we are going to discuss today. So it's almost 60%, 2/3 of your project B. Then the rest of the part is just implement the cost function. And so we have the such a selection option, and also join condition. We have the nested loop, and the single loop, sort merge, and hash join. For example, the hash join has been used a lot for the database, but in your implementation, I'm not going to ask to implement the hash join, but you should be able to understand what is a hash join. Okay, then for the heuristic, what is the idea of the heuristic, the optimizer? With the right limit, please narrow down search area. Okay, instead of accessing the entire table, suppose the extreme case we have the millions of queries in employee table. Okay, however, if your query has select from employee where the city name is the Bridgeport. Bridgeport and any other option. Bridgeport is, for example, employee from the Bridgeport is only 10, okay, out of 1 million. Then we can quickly narrow down the search area no matter what condition we have, okay, something like that. So we try to apply the operation that can reduce the size of the search area first. Also, if we select only last name and first name here, we can focus on the last name, first name, the column. We don't have to keep the other. So at the beginning, we try to apply such a approach. That is a heuristic approach. So heuristic approach, there is no general rule, but the idea is why don't we apply the operation that can reduce the size of the data. That's the heuristic. However, this heuristic had they're using a lot in the real database management system, because the query optimizer, which is based on cost function is still very expensive to be completed. Okay, it takes a time. So why don't we reduce the number of cases using heuristic first? Obvious thing. So just like the as if you are traveling to New York, obviously you are not going to consider the airplane or the cruise or ship. Instead, you try to focus on the possible, okay, option, like 2 or 3 options, like the Greyhound or MTA, or driving yourself. For example, if you do not have driver license, then definitely you cannot consider such a thing. So obvious thing, obvious method, obvious case, you can rule out. That is the heuristic approach. However, in your the project, you don't have to implement the heuristic. But if you implement the previous mentioned, okay, it's not actually the complicated idea. You can reduce the number of cases. Think about it. If you can implement the fully at first, then why don't you think about the heuristic approach that mentioned in your the writing up? You implement such a heuristic. Okay. So mostly we are talking about such a cost-based optimizer. There is another one in the relational database management system. That there are 2 strategies for the query optimizer. So it's a rule-based optimizer. Do you remember that? We have the rules to travel the New York. If there is the, so whenever I travel, I have the rule. If there is an airplane, I will take it. And if there is the train, that is the second option. If not, the last option is walk. Okay? That is my rule, no matter where I go. For example, if I want to travel to the Stanford, okay? So my rule is there an airplane? If there exists, we can take it, no matter how much expensive it is. Okay? That is a rule-based. That doesn't make sense sometimes, but it's simple. So rule-based approach is still used in many the simple the DBMS system, but not much the very expensive, like the Oracle. They support the rule-based optimizer, but the nowadays the default option is cost-based optimizer. So we will take a look at what is the cost-based during optimization. It will be based on what? Cost. What is the cost? Cost can be time. How can you measure the time in your program? It's very hard. Sometimes it can be the CPU time. It can be total time, so turnaround time, response time, or word clock time. So it's very hard to measure the such a time in computer. Instead, we will consider the access cost, the secondary storage. That is the lowest time comparing to other. Yeah, definitely. When you learn the DBMS system, query optimizer, whatever, it needs the storage, computation, CPU, and the memory access, and the network, the latency, and bunch of other the resource, but among the most expensive one. What determines the total amount of time? That is accessing the secondary storage. Instead, we can calculate the cost by counting what? Number of I/O. That's our goal. It's also simpler than the real case, but that usually works. Okay? So we are going to calculate for each case. So when we execute this one, when we make the plan to travel to New York, so there are a bunch of other, so write down case 1, case 2, case 3, option 1, option 2, option 1000. Then for each option, we will consider time or money or effort, whatever. Just like that, in our execution at the query optimizer, we have a number of the option. For each option, we will count, sum up all the number of I/O. Okay? Using what? For each case, do you remember S1, S2, S3, S10, and J1, J2, J3, J4? For selection condition, join condition, we define the cost function. Cost function means it's a function to count number of I/O. How many I/O are required for brute force? How many I/Os are required? The binary search. How many I/Os are required? The primary index access, something like that. So the last time, before we discuss about each cost function, so using this cost function, we will, for each option we have the something 10, 20, this one is 30, which one is the lowest one? This one. So we select option 1 as the execution plan, as the travel plan to the New York, something like that. Okay, so this is what optimizer is doing. That the problem is this function. How can we calculate? How can we sum up the number of I/O? So before that, we define the notation. First, you need to understand what is the N, what is the B, what is the S. Okay. So first, so number of record for each table. This is for each table. So number of record or number of tuples are. By the way, how can you get the number of the record R? Where can you get? From the real table. Employee table, department table, you need to count it. Okay, before run the execution plan, you need to have the information about such a thing, such a table. Then it makes sense when you have the small table. What about the huge table like the 1 millionth of the record? Even it takes a time to count, right? So from time to time, instead of collecting such an information entirely, we can use some sampling based on statistics. So we can access only 1% of the data, then the guess, estimate using statistics. So then, finally we can get such a data, so number of the record and number of record size and number of blocks, how many blocks are needed to access employee tables. Employee tables are stored and at how many blocks? To understand this one, you should know what is a block. What is a block? Block is data structure. At the beginning of the semester, I mentioned that all the things that we discussed, and also Professor Lee asked, answered by the data structure. It's a data structure for what? That's more important. Input and output. It's not only the database concept, the block is used for network. In network, it's called packet. Do you remember the packet? What is a packet? It's the smallest unit to send and receive the data. Then each packet will be structured. It's a data structure used in network. Similarly, when we read the data, we are not going to read bit by bit, right? Byte by byte. Instead, we are going to read the block by block. Operating system uses such a block, the data structure, to read the data. Which means when you read just 1 byte of the data, does operating system return 1 byte of data only? No. Instead, operating system asks the disk controller. Then disk controller will return 1 block that includes the byte requested. Why? It's a waste of time and waste of space. Why do you return entire block instead of 1 byte of data?
Because you want it to be consistent.
He's right answer. It's correct?
Yeah.
Really?
No.
No? What do you think? Why? Yes.
They might need the neighboring information.
So neighbor information may have higher chance to be retrieved. Then why do we consider such a higher chance? For
the I/O.
yes. In other words, performance. So for example, if I call his name, okay, then probably the next student, the aligned by the ID or higher chance, right? For advising. So you can guess. Or when I call your name to check that your midterm exam, so maybe the next. So similarly, when a CPU computer accesses data, it's not always linear, okay, but may have it's called the locality, okay. The next instruction may have a higher chance belongs to the same algorithm, so to be called. Then, if we upload the entire block, my class, I don't have to call 1 by 1. The next, I can check the next data from where? Memory. That is a cache. It's the same thing. It's more important in database. So database use bigger size of the block, usually 2K, 4K, while the operating system use 512 in general the block size. Okay, so that is the number of blocks. So even though the database need to access only 1 record, no, I/O is the minimal unit, the smallest unit for I/O. So what we count? Actually, the number of blocks. Okay, then blocking factor will be used. Blocking factor means how many records are in 1 block on average. Okay, that is called the blocking factor. So if we know some information about this one, we can calculate the number of blocks. For example, the employee table here is 1 100 record. R. Okay. Then we have the block size 512 byte. So block size. Then what is the blocking factor? How many blocks record are in one block? On average, how many?
Depends on divide both sides.
So on average 5.12, right? But it doesn't make sense, the decimal point, so we can floating, then that will be 5. So on average 5 record for each block. Okay, so for example, when we learn this query, the CD has selection cardinality 20%. Okay, for example, it's just an example, 20%. The 20% of the data will be written, which means the 120% is a 20 record will be written, which means how many blocks will be required to return such a data. Blocking factor is a 5, so 5 record, so divide by 5, 4 blocks. So estimated the number of blocks to read the data is 4 blocks, something like that. So this information will be used very importantly used in the cost function. And the others, this is for indexing. I understand that we do not cover the indexing part yet, so I try to find my best for you guys to understand easily. But so if you do not understand fully, don't worry, don't panic. But next week you should be able to understand. Why don't you try to understand after we cover the indexing part? Okay, when you implement the query optimizer. But so as I said, the index is different from the data file. It's a different file, but different data structure. It will be based on tree structure. Then each node has what? Index entry, like your textbook. Textbook, when you look up the information using the index, that has the, for example, Lee is page 11, right? This is a pointer. This is the address. It's the same thing in database. So it's the index, organized, sorted. Right? Simply, not exactly same, simply less than 5. Or less than K is here. Less than the David. And goes to here, bigger than David. DEF goes to here, so you can find the L over here. With address or pointer over what? Real page where Professor Lee's information is described. Similarly, we have the data file. This is an index. This is a data file. Then we can find 11. Page 11, or the block number 11 has the Lee information. Then you can access it. At this time, how many I/O are needed? 1, 2, 3, plus 1. Why? Because you need to access the data file. Right? So number of 11 is important. And number of first level means that this is called the first level. Using first level, you can find Lee, index entry. Okay? This has been used to eliminate whether one is classified. So then finally you can find the address from the leaf node. That number of leaf node is called first level index block. And how many distinct values? For example, if you are using the disk, how many data will be written? So 20. But if you are using social security number, 1111111, how many data will be written? Only 1. Selection cardinality is 1. Which one will be better performance? How many blocks you need to? 1. This one is better. So number of distinct values is also important factor to to decide which one is the best one. Okay? And that is can be calculated by the selection cardinality. Selection cardinality is kind of histogram. It's kind of histogram. This is the value of the column, like the A, last name B, last name C, and last name Z. So has a distribution, right? The best distribution is a primary key because it has only one value, but not always. Like the department number has a different selection cardinality. So that's also important part to determine. So we will see the example. This is a general the idea of. So we take a look at this. Took a look at the selection cost function before. Yesterday I made before. The linear search. Linear search. What is a linear search? It accesses all the data, which means right now you can say all blocks. Right? So blocks. This one. How many blocks? I have 200 blocks. So you need to access 200 blocks. However, that's slightly different. If you are using the condition, like the for example, the SSN 11111. At that time, if you want to use the brute force way, linear search, or full table scan, how many blocks do you need to access?
B blocks.
How many? It's a total 200 blocks. Without using any index, just a full 200. It's on average 100. Why? Because sometimes it can be at least 111 here, but worst case, last one. So sometimes 1, sometimes 200. On average, it's divided by 2. That is this one, divided by 2. Not the record. This is not record. From now on, this is a block. Okay? Number of block is a cost, our cost. However, I change this one like this. Or social security number bigger than 11111. How many blocks do you need to access on average?
200.
It's we don't know. Even though you find the 111 here, it's not ordered by the 111, right? You need to access the last one up to the always the last one. So you need to access all block, not 200. It should be it's a 200 blocks, right? So all 200 blocks, that is the B. So you should be careful. Depending on this one. In your implementation, you need to, your program, query optimizer should be the differentiate, the equality and inequality. Okay? So then, binary search will not be used in your the example. Why? Because we are not going to use the ordered file. Binary search is not indexed. Instead, if your data is ordered, okay, as I said, index is different from the data file. Okay, your data will be stored at the data file only table. Index is additional data structure for what? You don't know. Don't daydream. So index is what? Only for faster accessing the data. It's a different data structure. Okay? So, however, binary search without, sometimes you don't have index. However, my data itself, like my textbook, is already organized by page number. It's already sorted. My data is sorted. At that time, how can you search the data? Brute force way? No, you don't have to. Instead, you can use binary search because it's already ordered. However, in our case, we are not going to use such a data file, ordered file, so you don't have to worry. However, in case you have, it can be log B based on 2. Why? You already learned in your
Because it's already defined.
advanced database structure, advanced data structure, or algorithm course 552. It's a 502. Is there anyone who are taking the 502? No? Algorithm.
It's advanced algorithms.
Yeah. So when did you have a midterm exam?
Yesterday?
Yesterday? I see. Okay. So it's already passed, right? Because I found the exam paper which is jammed in the copy machine. Today to copy not for you guys the quiz. I have the quiz for the next class, but it's jammed. But I guess the GA that just left without removing the jammed paper. But I found the pages, I guess, inside the copy machine, the Xerox machine. But fortunately it's passed, so don't have to worry. Anyway, so this is a binary search. So then what? So algorithm course you learn the binary search is cardinal half, cardinal half, cardinal half. The computation is not the linear, it's a logarithm. It's a huge reduction. Still good. The accessing method. So log b based on 2. Then what is this one? In case of the unique, then you can find that. Otherwise, you need to access the less of the data, like the inequality, right? Fortunately, this time in this order. So if you find here that costed this much, then after that, that is this cost, okay? Then the primary index 1, 2, 3. This is a level. 1, 2, 3. X is the level of the index structure that determines number of IO. Somebody may be curious. To decide whether less than this, bigger than this, it will cost, right? Do we consider such a cost? No. It's just a piece of cake compared to secondary storage IO. Okay, so we ignore. So instead, we focus on just the read data. How many? 1, 2, 3. X in case x equals 3. Then plus 1. What is the plus 1? It's always our goal is to read the data. One more data. That's a plus 1. In case of the hashing, it's a 1. It's just love. Actually, it's not 1. But we are not going to consider hashing in the project. So to simplify, it's very tough. Not tough, very complicated to find the exact cost function of the hash. We simplify it's just 1. Okay? In real cases, it's the same. So next, so we have the multiple record. In case of the multiple record, so once we find here 1, 2, 3 x plus the rest of them, b over 2. We did. It's a linear search, right? So we don't know how many of the data we are going to access, the rest of them. So it's the b over 2 on average, just that. As I said, this cost function is the exact cost function or log estimated cost function. It's estimated. We don't know. Even though you spend a lot of time to estimate the travel time to New York, is it exactly correct? You can estimate, but it's not exactly correct. It's log, okay? So it's the educational guess, kind of experience guess. So this will be over 2. Then, if we are using clustering index, what is a clustering index? Like the department number. So this is an employee, but organized by this is the index. Therefore, department number. This department number has, for example, 1 has many pages, right? So how many employees for the department number 1? Many, right? 2, many. So it has a many. So that is the selection. It depends on the distribution of the data. Department number 1 has 10. Department number 2 has 20, 3, 30, 4, 5, something like that. Then, depending on selection cardinality, how many data for each value of the department, then divide by buffering factor. Then we can have what? Number of blocks, number of IO, then ceiling. Okay? In case of 0, 1, that can be considered anyway 1 IO. Right? So that is this.
So the clustering index is also unique.
It's not unique index. Clustering index is not unique. It's a group index, like the group number 1, group number 2, group number 3.
Okay, but like,
We will discuss detail in the next class. I understand. There's a problem of teaching this one first, but roughly, the clustering index is not unique index. It's kind of group index.
every group has like unique cluster index.
Yeah, index, we will index that value. For example, we have that's the social security number and DNO in employee. This is a unique value.
Right.
When we index, how many index? Number of data, right? If we have the 10 employee, 10 SSN, 10 index value. DNO, how many departments? We have 2 departments. Okay, either 1 or 2. But when we index, when we make the index for DNO, we have only 1 or 2.
But it's the same thing for clustering index. Like if you want to access the first group or the second group, we have.
Yeah. Well then, if we access the first group, then anyway we need to access the all employee that belongs to the same group.
Right.
Yeah. So that costs this amount. Okay. So that is the clustering index. The secondary index definitely most popular. Okay, we will see why the next week. Well, how can we compute the B3 index? B3 index is the same as the other tree structure like the X. However, it has one of the benefits of using the B3 index is B3 is actually ordered by the key value in the first level. Okay, the social security number 111, 222, 333, 444, 5577, like the order. Okay, so then we can easily calculate the inequality. Unlike the primary index, previous one, we need to access the data. Here you can find the data from the index, leaf node, first level index. Okay, so both the equality and equality is the same. So that is the x. X is the level, and the second part is the number of blocks in the first level who include the index key. Then R is divided by 2 is the number of data because we don't know how much data we are going to access in equality. Okay, they are not sorted, it's not blocked. So this is the number of record divided by 2 in case of inequality. Okay, so next is the actually 7a. It is the combine. When we have the several conditions here, we can like the n. DNO is equal to 1. And something other condition, we can separate this one, this one, this one, this one. In case of conjunctive, we segment and compute the cost, select the smallest one. Okay? That is the conjunctive. So, example, that's what we did yesterday. We are going to use the same component database that I introduced at the beginning of the semester. Also, that has been used throughout the semester. So, you are familiar with this one. Also, what is the underline? Underline means primary key. Primary key has automatically index. Primary index. How can you check? What is the primary key? It's the not null and unique. How can you check the non-null and uniqueness in case of new data? How can you check? Compare with older data.
Yeah.
It's very expensive. So why don't you order the student by student ID? Then check whether 111 exists or not. Right? That's faster instead of checking. Do you have the 111 ID? Next detection is a brute force way. So why don't you order by ID? That's called index. So primary key always has primary index, even though it's not mentioned automatically. So that is the primary key. So underline means it has a primary key. One more thing. What is this one? What is this one? It's a foreign key. Okay? In case of foreign key. So, and what else? Social security number, and there's no employee ID. I think that's pretty much okay. So we will see the example. To do that, first we should know the information statistics of the company database. That's here. RE means employee table. Number of record. How many pupils for the employee table? 1,000, 10,000. Okay, so 10,000 employee. It's 10,000, right? So R is 10,000. And B of E means B indicate blocks, number of blocks. It's a 2,000 block. Then what is the blocking factor? In other words, how many record for each block? 5. It's divided by the number of blocks. Then you can get the 5. Okay. Then also we have the clustering index on salary. So here, this employee is ordered by salary. That's the index. However, sometimes there are employees who have the same salary, which means it's not unique. That means it's a clustering index. So clustering index, this index has a 1, 2, 3 level. Cardinality. What is the cardinality? It's the data distribution, which means for each salary, how many employees? 20 on average. So like the 10,000, 20 employees. Okay, 20,000. We don't know exact number, but on average. Okay, on average, when you select the specific salary, that will return on average 20 employees. Okay, that is this one. And secondary index key on SSN, that is primary key. Right, social security number, primary key. How many level? 1, 2, 3, 4. And selection cardinality. How many data will be returned when you select using social security number? Only 1. Because it's a unique. That's this one. Non-key attribute, which means DNO has the index. That is the level is 2. Okay? And first level, 1, 2, 3, 4. The first level index. I don't know. Okay? 4 block. And how many department? 125 distinct value. And selection cardinality for each. Actually, you can divide by 125. That is the 80. So on average, selection cardinality is 80. In other words, each department has 80 employees on average. And yes.
I mean, there's so many departments here.
In this, it's just an example.
125 departments, how big is it?
It's just an example. Don't pay attention too much to the meaning of this data. Even very hard to find the 10,000 employees in local company. Anyway. And also we have another index for the sex. In this case, how many distinct values? Man and woman. I'm not sure whether that's the problem. Man and woman and other, but anyway, man and woman. If you know transgender, it's either man and or woman, right? So there might be no problem. Anyway, the 2 distinct values. Selection cardinality is what? Divided by 2 is 5,000. Not exactly, this is just statistics on average. Yeah? Level is just 1. Okay? Then, using this information, we are going to optimize this. That's pretty much enough without join. We don't discuss yet the join condition. What's the time?
220.
220? same as what? Select, because there is no projection, it's the all from employee to test the selection condition only. So SSN equal 1, 2, 3, 4, 9. Once this query is submitted, it looks like a simple, but it has many different ways to access the data. We don't have to consider the join, but we have, for example, how can you access the employee? You can use the always brute force way, linear search, regardless of the indexing. So we can access the first option one, brute force way, linear search or full table scan. Another way, do we need to use the, for example, the DNO index? No, we don't have to. DNO is not used here. Okay? What about the secondary index for sex? Do we need to have to consider the sex? No, it's not involved. So you can consider option 1 through the all option, but obviously this is not. So but SSN is used in your query, which means there may be chance using SSN. In this SSN, this is a primary key. So that means we can consider this option. So for the first one, not this option, so we can consider for the first option, that is this one or this one. In this case, it's equality, so we can consider this option. Okay. Then this one is the primary index, so we can consider this x plus 1. So there are two options. So how many blocks? The first option, brute force way, is b divided by 2. How many blocks? So blocks are 2,000 divided by 2 is 1,000. If you select this option, which means the brute force way, it takes the 1,000 IU. And what about the next option? It's x plus 1. What is the level of that index? It's 4, right? So 4 plus 1 is 5 IU. This is 1,000 IU. Which one is better? Better means what? Faster, right? Low cost. Which one? Option 2. Then your optimizer will suggest to use this one. Access employee table using primary key. Okay? That's what you guys need to do. Not complicated. It's a simple. So already given the cost function. Right? In terms of the program, it's not very good. So I'm not going to write all of this, but this one, employee, DNO, bigger than 5. It's an inequality. So at that time, always brute force way it will be considered. Sometimes the brute force way is faster than index. That's true. Okay. Then in this case, we have the index for DNO. That's this one. Okay. Then we can use which option? So cluster index. What kind of index is this? You need to check. It's a non-key. It's not clustering index. It's just a non-key index. It's a secondary index. So secondary index use this option. So you should know that this one, how many? Lift is 4. Lift 4 blocks. Then you can calculate 4 divided by 2. This is the level and number of the record divided by 2. So roughly 5,004. Yes.
How are we getting the x?
It's a given.
Oh, it's given. Okay.
Yeah. So how can in real system how can you get? Who will give?
You said unknown.
you need to collect such information. So most of DBMS provide a function or tool to collect such a data. Okay. What about the 10 years ago data?
You got the cloud.
What about the every second you collect the data? That does make sense, right? So that's one very important thing which is easily ignored or overlooked. That is how often you are going to update such a metadata. Okay. In other words, how often you update your phase 1 of project B. Okay? That is what you are going to. But in this case, in your project, you are going to manually input using the SQL. Okay? Then in real case, the DBMS, the provide a function. For example, Oracle provide analyze function. If you type the analyze system like table, it will collect this kind of information. It takes some time. So you should learn this kind of command at night or when